Let's take a look at Lesson 13, which has to do with common factors and difference of two squares. If we want to get a concept of the word factor, if we take a look at 100, these are the numbers 1, 2, 5, 10, 20, 25, 50, and 100, which can evenly divide into 100 without a remainder. So these are the factors of 100. If we take a look at the number 60, 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60 can be divided into 60 without any remainder. So 60 has more factors than 100. However, there are special factors such as 1, 2, 5 here that are called prime factors because any other number such as 10, 20, 25, 50, or 100 can be made up of combinations of these prime numbers. The same thing here with 60, 1, 2, 3, and 5 are prime factors, and all other numbers such as 4, 6, 10, 12, 15, 20, 30, and 60 can be made up by multiplying a combination of these prime factors. Now this is covered in example 2 as well. Two factors of 30 are 5 and 6, but only 5 is a prime factor. 6 can be made up by multiplying 2 times 3. So 2, 3, and 5 are the prime factors of the number 30 that's here. Now this also applies to expressions such as x, x minus 3, and x squared minus 3x plus 7. These are all prime because they cannot be factored further. They can't be broken into simpler expressions. However, expressions such as x squared minus 9 and x squared plus 5x plus 6 are not because they can be factored further. For instance, if we take a look at x squared minus 9, for instance, we can say x minus 3 times x plus 3, and this will indeed give us this expression here. Also, x plus 3 times x plus 2 will give us x squared plus 2x plus 3x plus 6, and when we combine terms, we will get this. So we can actually factor this expression into x plus 3 times x plus 2. Now in the past we've been given an expression like this, and what we've done is we've multiplied through x times x to get x squared and x times 4 to get 4x. And that's how we basically find the product through multiplication. Well, what happens if we're given this term and we want to go back the other way? Well, one of the things you have to realize is that x is a factor here of x squared and x is a factor here. And because it is, we can put x out on the outside and then figure out what times x is going to give us x squared, and that's x. What is going to give us 4x, we multiply by that, it's this, and then we can come up with this particular factor for x squared plus 4x. And similarly, in this common factor here, we can see the b and c are not common, but the a is common here and here, so we can write a out in front. And then a times b plus a times c gives us this. So this is our factor for this expression here. Let's take a look at example 5 here, and we have 2x plus x squared. Again, we have x here, we have x squared, so we have a common factor of x. So if we put x in front and then say what times x is 2x, we can put a 2 here. What times x is x squared? Then we can get x squared by doing this, and this again becomes a factor here of that expression. When we look at this expression, you have to make sure that it has, say, x in all the terms before we can actually factor it out. If x is not in all the terms, we cannot factor it out. And we want to make sure it's the highest power of x as well. So x cubed, x to the fourth. So this is the one that we're going to factor here as x. So x times 3x squared will give us our 3x cubed. X times minus 2 will give us our minus 2x. And then we can say that x times 5x cubed is going to give us our 5x to the fourth. That means that this is our factor of the original expression. Now in part B, we can take a look, x and y, x and y, x and y. So we can take out x and y, but we can also see that of our numbers here, 3, 9, and 6 is also a factor. So we can take out a factor of 3xy. And so 3xy times what is going to give us 3xy squared? That's times y. And if we want to get 9x cubed y, 3 times 3 will give us the 9. The x squared will give us x cubed, and the y out front will give us that. So this is this term done. Then we have 6x squared y. So we multiply 3 times 2, that's our 6. X times x is x squared. Y times y is y squared. So when you look at this, this is the factored version of our original equation. Notice here we have a factor that's common here of 1 over x. And so we can have 1 over x here times 1 will give us this part here. And 1 over x times 2 over x will give us 2 over x squared. So we can validate that this expression here is the factored version of this. Now you have to be careful again, there's a y here squared, a y here, and a 3y. So the lowest factor of this is y. So that's all we can take out here. If we look at the top, we have x, x squared, and 2x. So x is the least common factor here. So these are the two that we can take out, and then we have to rebuild it so we have our original thing back here when we multiply everything through. So if we want x over y squared, that's x over y. X times 1 will give us our x. Y times y will give us our y squared. So this is part of the term here. To get the x squared over y, this is going to give us x squared, and this is already over y. So at this point, we have everything validated down to these first two terms. To get the last term, we have to get 2x over 3y. This will give us our 2x. This will give us our 3y. So you have indeed, by doing this, shown that this is the factored version of this expression. Let's take a look at factoring this expression. Now we all have powers of x here, and the smallest power of x is x to the 3. So we're going to work with that as our common factor. Notice our coefficients here are 1, minus 1, and 3, so there's nothing we can do with those as a common factor. So we're going to say x cubed. Now we have to remember our rules of exponents. X cubed times x squared is going to give you x to the 5th, which is what we want, minus 2 x cubed, so that would be x, because x cubed times x is going to give us x to the 4th, and finally plus 3. To validate that this is a proper factor here, let's expand it back out. So this is x to the 3 times x to the 2, which is x to the 5. This is x to the 3 times minus 2x, which is minus 2x to the 4th. X cubed times 3, it's going to be plus 3x cubed. So indeed, this is indeed the proper factor. When we try factoring this expression, we can see that we have terms in 5 and x plus y. So if we say 5x plus y times 1 would give us this term back, plus 3 times x plus y would give us the other term back. So this would be 5 bracket x plus y plus 15x plus y squared. So this is indeed the factored solution for this one. Now in any expression we have to find out the terms that are common. So a is common here, here, and here. B is common here, here, and here. But C and D are not. So what we can do is write a, b, bracket, and then 3a. So this would give us 3a squared b plus c minus d. And if we expand that out, we will indeed get this. So this is the factored version of this expression here. Let's take a look at this expression and try and expand it. This is a times a, which is a squared. A times minus b, which is minus ab. B plus a, which is plus ab, minus b squared. So these terms cancel out and we're left with a squared minus b squared. This is called the difference of squares. So anytime you see an expression like this, you can always break it down into this kind of expression where you have a plus b times a minus b will give you the difference of squares. If we want to factor this expression here, we can realize that 4 is 2 squared. So we have 2 squared x squared. We recognize that 9 is actually 3 squared. So we could write this as 2x squared minus 3 squared. And this difference of squares means that we would have the first term 2x minus 3 times 2x plus 3. Let's see if this validates out. So we have 2x times 2x, which is 4x squared. We have 2x times 3, which is plus 6x. Minus 3 times that is minus 6x. Minus 3 times 3 is minus 9. So when we cancel the terms, we do indeed get 4x squared minus 9, which is our original, which means this is indeed the factor of our equation here. Let's take another look at factoring. A to the fourth is really a squared to the second power, and we're subtracting b to the sixth, which is really b cubed to the second power, because remember 2 times 2, 3 times 2. So in this case we can easily write this in as a squared minus b cubed times a squared plus b cubed. Let's validate that this is indeed our proper solution. So a squared times a squared is a to the fourth. A squared times b cubed is plus a squared b to the 3. And then the inner terms is minus a squared b to the 3. And then minus b to the 6. And if we cancel out these terms again, we get a to the fourth minus b to the 6. And this indeed validates that this is our factor. Let's take a look at factoring the difference of two squares with fractions. 1 over x squared can be rewritten as 1 over x all squared, and 1 over y squared can be written as 1 over y all squared. And if we apply the rules that we had, it's going to be 1 over x plus 1 over y times 1 over x minus 1 over y to give the same thing as we've gotten before. Now this one is a little different. You've got a plus b squared minus x squared. So if you remember, this is a plus b, just treat that as just one term, plus x times a plus b minus x. And when you expand it out, you're going to get a plus b plus x times a plus b minus x if we just take out the brackets.